Have you ever felt a spark of static electricity or seen a compass needle point north, guided by an unseen force? These phenomena are caused by electric and magnetic fields, fundamental forces of nature that surround us every day. Electric fields are created by charged particles, like the electrons that flow through our electrical wires. Magnetic fields, on the other hand, are produced by moving charges, such as the current flowing through a wire or the spinning electrons within a magnet. These fields, though invisible, possess real energy and can exert forces on other charged objects. Imagine an electric field as an invisible web surrounding a charged object. If you place another charged object nearby, it will experience either a push or a pull, depending on the types of charges involved. Opposites attract, so a positively charged object will attract a negatively charged object. Like charges repel, meaning two positively or two negatively charged objects will push each other away. Magnetic fields behave similarly but act on moving charges and magnetic materials. Visualize a bar magnet with its north and south poles. Just like with electric charges, opposite poles attract, causing the north pole of one magnet to pull towards the south pole of another. Conversely, like poles repel, so two north poles or two south poles will push away from each other. These fields, though seemingly separate, are intimately intertwined. They're like two sides of the same coin, forever linked in a cosmic dance. This connection is what gives rise to the fascinating phenomenon of electromagnetism. When electric and magnetic fields interact, they create a unified force known as electromagnetism. This interaction is not a static relationship, rather it is a dynamic dance where changes in one field induce changes in the other. Imagine a simple electrical circuit with a battery and a light bulb. When the circuit is closed, electrons flow from the negative terminal of the battery through the wire and back to the positive terminal. This flow of charge, or electric current, creates a magnetic field around the wire. This magnetic field is not constant. It fluctuates in strength and direction as the electric current changes. Now, picture a wire moving through a magnetic field. The movement of the wire within the field causes the electrons in the wire to experience a force. This force can induce an electric current, demonstrating how a changing magnetic field can create an electric field. This beautiful interplay between electric and magnetic fields is the foundation of electromagnetism, a fundamental force of nature that governs countless phenomena in our universe. Electromagnetism is not just a theoretical concept confined to textbooks, it is a tangible force that shapes our daily lives. From the moment we wake up to the time we switch off the lights, we are surrounded by devices and technologies that rely on the interaction between electric and magnetic fields. Let's take a closer look at some real-world examples. One of the most common examples is the electric motor, found in everything from household appliances to electric cars. Electric motors utilize the interaction between electric and magnetic fields to generate rotational force. An electric current flowing through a coil of wire within the motor creates a magnetic field. This magnetic field interacts with the magnetic field of a permanent magnet, causing the coil to rotate. This rotational force is then used to power various mechanical systems. Another ubiquitous example is the electric generator, which works on the opposite principle of an electric motor. In a generator, a coil of wire is rotated within a magnetic field. This rotation induces an electric current in the wire, effectively converting mechanical energy into electrical energy. Generators are essential components of power plants, where they are used to produce the electricity that powers our homes and industries. These examples illustrate the profound impact of electromagnetism on our technological advancements and the convenience of our modern lives. As we have discovered, electromagnetic fields are not just abstract concepts, but rather powerful forces that shape our world and drive technological innovation. From the simple act of turning on a light to the complex workings of our smartphones, we are constantly interacting with and benefiting from the principles of electromagnetism. Consider the wireless technologies that have become integral to our lives. Mobile phones, Wi-Fi routers and Bluetooth devices all rely on electromagnetic waves to transmit information wirelessly. These waves, consisting of oscillating electric and magnetic fields, travel through the air at the speed of light, enabling us to communicate and access information from virtually anywhere. Medical imaging technologies such as magnetic resonance imaging, MRI, also harness the power of electromagnetism. MRI machines use strong magnetic fields and radio waves to create detailed images of the inside of the body, aiding in the diagnosis and treatment of various medical conditions. As we delve deeper into the realm of electromagnetism, we uncover a universe governed by interconnected forces. The interplay between electric and magnetic fields not only shapes our technological landscape, but also plays a fundamental role in the very fabric of our universe. Understanding these interactions allows us to appreciate the intricate workings of the natural world and harness their power to improve our lives.